most welcome to 1543 out here in lovely Jonsered. We're having sunshine all over the place now. It seems that spring is finally breaking in here in this part of Sweden. It's already getting a bit warm here in this very glassed room. Today we have a newcomer on the scene of science, philosophy, understanding. Although there are two authors, Nicolas Gisin from Geneva University is the most prominent. And this is absolutely fresh stuff. My colleague Kalle here will present Nicolas Gisin.
I don't have so much to add, but that he works at the University of Geneva. And in 2014 he published a book, Quantum Chance. Where he explains modern quantum physics and its applications without using mathematics or difficult concepts. The text has been translated into French, from French into English, German, Chinese, Korean and Russian. So we should perhaps read this Quantum Chance. And that's what we are trying to do, explain quantum physics without using mathematics or difficult concepts.
Definitely.
So thumbs up for Nicolas Gisin and for your good luck with your lecture.
Thank you very much. Yes, this is rather exciting. This is so fresh. The article I will read today is handed in July 2022, accepted November last year, and not published until late November last year. So to speak, it is fresh from the print. Let me start with the abstract here. Discussions on indeterminism in physics focus on the possibility of an open future. That is, the possibility of having potential alternative future events. The realization of one of which is not fully determined by the present state of affairs. Yet, can indeterminism also affect the past, making it open as well? We show that by upholding principles of fitness of information, finiteness of information, sorry there. Finiteness of information, one can entail such a possibility. We provide a toy model that shows how the past could be fundamentally indeterminate, while also explaining the intuitive and observed asymmetry between the past, which can be remembered at least partly, and the future, which is impossible to fully predict. introduction, one of the fundamental questions in the philosophy of physics aims to establish whether the evolution of every physical system is governed by determinism. That is, if any two states of a system at different times are related by a one-to-one connection, or if future events can in principle have multiple potential outcomes that are not fully determined by past states. While for centuries it was believed that such a deterministic account is uncontroversially true, mostly due to the empirical success of the equations of motion of classical physics and their mathematical properties. The advent of quantum physics raised a lasting debate that leans towards the solution that the world is actually indeterministic. In recent years, we have proposed that even classical physics should be interpreted indeterministically. If one assumes that the reasonable principle of finiteness of information density, that is, the finite volumes of space can only contain a finite amount of information. Indeterminism certainly grants to the direction of time a fundamental role, for changes really happen while time passes from an array of mutually exclusive potential events. Only one obtains. However, once one event has been actualized, it is considered determinate, and this status does not undergo further change as time passes. While the future is open in an indeterministic world, the past is there to stay, as encapsulated also by C.F. von Weizsäcker when stating that the past is factual, the future is possible. Nevertheless, some authors in the philosophical literature, notably Lukasiewicz and Dummett, have hinted at the possibility that upholding indeterminism could have consequences for the past too. Yet this idea that the past could also not be fully determined by the present state of affairs at a fundamental level in an indeterministic world seems to have been often overlooked, even within the numerous debates about indeterminism. That is, in a nutshell, the point of the article. Indeterminism leads also to a possibility of the past being indeterminate. It is the aim of this paper to revive the question, can the past be open? Hoping that this will motivate further attempts of addressing this problem. It should immediately be noticed that while we are in general not able to predict the future with certainty, which leaves room for a philosophical debate on whether to interpret this as either a lack of knowledge about the underlying determinism or as fundamental indeterminism. We do seem to remember the past. That is, it exists information about the past that can in principle be remembered with certainty. This therefore begs the consequent question: if the past is open, why do we observe such an asymmetry in terms of predictions, retrodictions? In what follows, building further on principles of finiteness of information that entail indeterminism, we provide a toy model that aims to show how well the past as well could be fundamentally indeterminate, while explaining the intuitive asymmetry between the past, which seems determinate in our recollections, and the future, which is in general impossible to fully predict. Second subtitle, can the past be open? In the most general sense, without any ontological commitment, the laws of physics can be regarded as causal relations that connect pure states of a system at different instants of time, given a suitable conception of a time arrow. Note that the pure state is, in this case, generally defined as the state encapsulating the maximal amount of information existing at present about each relevant degree of freedom of the system itself. Note that, as in our previous works, we uphold a physical interpretation of information. This is very important. I call that PI.
Physical interpretation.
Physical information. This means that information becomes meaningful only when embodied in distinguishable states of a physical system. In the words of Landauer, who pioneered these ideas, information is not an disembodied abstract entity. It is always tied to a physical representation. It is represented by engraving on a stone tablet, a spin, a charge, a hole in a punched card, a mark on paper, or some other equivalent. This ties the handling of information to all the possibilities and restrictions of our real physical world. Its laws of physics and its storehouse of available paths. In the broadest possible sense, two events, named the cause and the effect respectively, are said to be causally related in the case that if C obtains, it influences the tendency for E to obtain. Note that for this to happen, C must happen before E. Following this general definition of causal laws, in the present note, we consider different examples of indeterministic physics, showing that indeterminism can entail not only the known indeterminacy about the future, but about the past as well, which truly evaporates as time passes. We know that information disappears because material in the universe disappears. That will also mean that history changes. Gisin and Flavio continues. By this we do not mean merely an epistemic statement, namely that it is our knowledge of the past which evaporates. Rather, it is the available information that disappears from some degrees of freedom of the universe that were encoding it. And therefore, it ceases to exist altogether. One, deterministic causality and spontaneous acausal events. In orthodox classical physics, it is assumed that causally connected events are all related by necessity. That is often called deterministic causality. The causal connections are in this way fixed for all times. That is, every event that obtains is the certain, and listen now, certain result of the previous events that obtained before, without the possibility of alternative ones. This forms a causal chain, all given at once, ad infinitum, towards both the past and the future. And we already brought up this in the series about the future, that it is not determined. Nicolas Gisin is putting it up a notch, quite a notch. Listen carefully. However, possible alternatives have been already considered in the vast literature devoted to determinism or indeterminism. As a first example, considered in the vast literature, as a first example, consider the following possibility to avoid a deterministic world, even if one maintains deterministic causality as the norm. some authors had it that it is possible to conceive that the chain of necessary cause-effect relations is from time to time interrupted by an acausal event that spontaneously obtains independently of any other previous event. That is complete independence. Note that this is not the position that we endorse. For the concept of genuinely acausal event that suddenly arises out of nothing seems arbitrary and unsatisfactory. More formally, if the events that are one the cause of the other are represented as nodes in a directed, acyclic graph, spontaneous acausal events may create disconnected parts in the graph. This possibility clearly leads to the openness of the future, insofar as some future events may not be inferred, even given complete determinacy of all the events that are causally connected to the present and to the past, because a possible future spontaneous event can create a new, unpredictable, disconnected subgraph of the whole causal graph. In a similar fashion, Lukasiewicz suggested that the same conclusion should be reached about the past. And now we're taking it up a notch. I need some extra stimulants here. If no causal connections still exist at present with a certain past event, or more realistically, a whole past disconnected subgraph, that event should not anymore be considered determined. In his words, facts whose effects have disappeared altogether, and which even an omniscient mind could not infer from those now occurring, belong to the realm of possibility and not the realm of actuality. One cannot say about them that they took place, but only that they were possible. In what follows, we would not further consider this somewhat unsatisfactory approach of disconnected deterministic chains, but rather develop a framework of causally complete, yet fundamentally indeterministic physics. As you can see in the previous here, events can be uncaused in the deterministic way because of lack of information. This is what Flavio and Gisin calls the finiteness of information. And the finiteness of information is getting more and more acclaim these days. 2.2. Probabilistic causality and finite information. I'll call finite information as a very important. Two, probabilistic causality and finite information. Since the mid-20th century, philosophers of science such as Popper, Ehrman, Salmon, Dow, Reichenbach, Good, and Supps have generalized the concept of causality to indeterministic scenarios, developing the idea of probabilistic causality. This states that an event C affects the tendency of another event E to happen, but E is not bound to happen by necessity. This generalizing the Leibnizian principle of sufficient reason. There is nothing without a reason, or no effect without cause. But causation is here meant as a looser connection between events than determinism. The standard way to quantify a tendency for an event to happen is to make use of probabilities. In this case, however, probabilities are thought of as propensities, that is, objective properties of a physical system in relation to an idealized environment to change from a pure state to another. Yes, that's a tough nut, but it will become clearer. In a probabilistic causal scenario, events can be graphically represented as embedded in a directed and acyclic multigraph with two types of edges. The first edge, the first type of edges represents a potential causal connection, and each of these edges is weighted with a propensity that relates to events, that is associated with a non-negative rational number, such that the sum of the weights connecting a cause to all possible mutually exclusive events is equal to 1, meaning it's happened. The second type of edges represent instead an actual causal connection, picking only among the mutually exclusive potential causal connections. The potential graph represents all the possible alternative histories, and it seems prima facie independent of time that one is considering, always given that the information is finite. However, the values of the weights evolve in time. Here we have the wonder. The values of the weights evolve in time. Say this is one of the things that's previously overlooked. It's a bit tough still here, but do bear with me.
Can you repeat the sentence?
It's the last sentence on page 4. However, the values of the weights, that is the propensities, evolve in time. They are not fixed once and forever. Something that I never thought of until I read this article. Maybe the second reason I didn't get good sleep. But all for good reason. The graph of the actual causal connections instead develops in time out of the former. And it is only when the propensities evolve in time, taking the value 1, thereby ruling out the potential alternative effects to which the corresponding propensities all take the value 0. That this can be constructed. Note that this implicitly defines the concept of the present, which is the time slice that separates the subgraph containing exclusive events connected by propensities 0 or 1, that is the past, from the subgraph that contains arbitrary propensities, which is the future. all very elegant. And do give it some time. I will try my best to help out. A clarification on the concept of event seems in order. In standard probability theory, an event is an element of a sample space. Helpful to remember. Which, together with a sigma algebra and a measure function, defines a probability space. Let me get some comments here. So probability is the same as space. Because there is no space without something happening there. Remember, we left the Newtonian Cartesian in active space. Modern space is always an event of a sort. Here, we do not necessarily assume that the propensities are probabilities at the formal level, although they intuitively play the same role in quantifying likelihood. Hence, when we refer to an event, we mean anything that the theory can talk about, namely any proposition to which it is possible to attach a measure of likelihood. That is, could happen. In particular, one can relate the current theoretical framework in terms of events to our proposed indeterministic interpretation of classical physics based on finite information quantities, here called a FIC. There will be some complications later, but I will skip it, but this one is not that bad. A FIC. Finite information quantities. And as I mentioned before, the whole thing is based on this, that information is finite in the universe or in any space. A FIC is an array of propensities that quantify the tendency of each digit of a physical variable to take the value 1 under the constraint that the total information content of the array is finite. An event can in this context be thought of as the actualization of a digit of a fic. It should be clear at this point that a probabilistic view on causality entails indeterminism in the sense that empirical statements about the future are in general undecidable. They are neither true nor false, not even in principle. So that is the light cone once more. To say whether it's going to switch from yellow to green is without truth value until it happens. And that's a cause of indeterminism, or not following determinism, if you like. This makes the law of the excluded middle fail. Very important. So you see here, I would say here, it won't fall by itself, as Graham Priestley suggested. We need this new understanding of indeterminism. But now it will definitely fall. I think I have to read the whole long sentence. And that's the second paragraph on page 4.
The beginning of the edition I have on it on page 3.
Okay, could be page 3, thank you. It should be clear at this point that a probabilistic view of causality entails indeterminism in the sense that empirical statements about the future are in general undecidable. They are neither true nor false. And now it comes. Not even in principle, despite having complete knowledge of all the existing information of the present pure states. This makes the law of the excluded middle fail, relating to the problem of indeterminism and undecidability of empirical statements to mathematical intuitionism. The whole half paragraph is very well worth remember and quote. And of course, this is age-old. Laplace is now proven false. So it goes back. Laplace said, give me all the coordinates, all the forces, all the momenta of the universe, and I can calculate every happening, both in the past and the future. And I think Laplace more or less have been holding air until now. So the first example comes here. In this way, propositions the likes of "it will rain in Paris in a year from now" or the position of a certain particle will be on the left side of a plane at the future time tf, do not at present have a determinate truth value. Not only, and this is also important, not only because this might be unknown, because it is not yet determined. So it's not about things we don't know in the universe, which I think most people assume. Until it happens, it cannot be determined. Not because Dummett pointed out that this kind of fundamental indeterminacy, which he misleadingly, and I also like that, called anti-realism at first, is not only a feature of future events, but it extends towards the past as well, when no trace is left that would allow one to decide the truth value of a proposition about the past. Only, and a quote from Dummett, only those statements about the past are true whose assertion would be justified in the light of what is now the case. And how do we have a sort of a conclusion? This means that there is no one past history of the world. Every possible history compatible with what is now the case stands on equal footing. On this note, we would like to point out that Dummett's misleading term, anti-realism, was supposed to actually refer to indeterminism. This confusion is quite widespread, and I solemnly agree. I had it myself. This confusion is quite widespread, as one of us pointed out. Sometimes realism is defined as the hypothesis that every physical quantity always has a value. But then, either this value is inaccessible, hence unphysical, or this value can be revealed by appropriate measurements. Hence, these measurements have predetermined outcomes, and realism is nothing but a fancy word for determinism. Oh, he really punches hard. In fact, our proposal in terms of objective propensities maintains realism while introducing irreducible indeterminism. Similar considerations to the ones hinted by Dummett can be refined by making use of the concept of information and its relation to physics. Within probabilistic causality, in fact, the state of a system can thus be regarded as the piece of information recording the whole multigraph. Also important. Physical and information is one of those dichotomies that is questioned here by Flavio del Santo and Nicolas Gisin. They have previously come into question, of course, mentioned many times, for instance by Carlo Rovelli and Lee Smolin. But now there is definitely extra punch to the argument. Within probabilistic causality, in fact, the state of a system can thus be regarded as the piece of information recording the whole multigraph. That is the ordered collection where ET is the set of all events. And I will skip a bit here and go to, let's see, the last sentence on page 7. Let us now assume that, it starts with, and then we have a depiction. 1. The universe is finite. It has the finite resources occupying a finite volume of space. And this is pressed once more. All space, my comment, has a finiteness of information. It's not freely available. This, together with the principle of finiteness of information density, recalled above, means that the total amount of information in the universe is also finite. Suppose that this total amount of information storable in the universe is upper bounded by n bits. That's information, the quantity of information. 2. By homogeneity of time, this maximal amount of storable information in the universe is symmetrically centered around the present instant. and call it a now. And I continue with the text. Since the amount of information is bounded, it's in a certain now or event, so to speak. While time passes, the finiteness of the information requires some past event to be erased. We have a limited amount of information in the universe. If something happens, some information has to go to cover that happening. This would mean that the past as well could be open again, as the amount of information of which event caused the earliest in time recorded event forces it to be erased. Having lost information about the propensities of the past event, it remains only to assign equal weight to the alternative potential past events. Can you even hear potential past events? It's like the present is telling what past events are possible because of the lack of information. There's a name for it here, which we may call random past causal connections. This leads to the concept of an open past. That is, not all the propositions formulated at present about past times are determinate. For instance, the question, was the event E at the time T caused by the event C at the time earlier than the present, is in general neither true nor false for times I sufficiently far away in the past. And all of a sudden here flies the excluded middle also for the past, making the past as indeterminate as the future. So you can imagine, I'm going to put the pause there, I'm just going to make a quick summary and then fix the whiteboard. You can imagine this is hot stuff. Questioning the past is, as even one of the proponents of this thinking done it, one of the early ones, think is anti-realism. It is not. According to Gisin and Flavio del Santo, this is what quantum mechanics teaches us. And ignoring this, it's been popping up here and there during history, has been the savior for the age-old determinism. But there is more to this punch. It's a bit of a undercut, and then there is a hook. Why? Well, it actually takes away determinism within classical physics as well. So classical physics doesn't go scathe-free from its supposed important determinism. And we can put a pause there. So I'll make a little summary and repeat some of the key concepts on the whiteboard. But let me just emphasize this. This is an incredible saying of Nicolas Gisin. And it is very recent. It's a development in what has taken only a few years of revelations from Nicolas Gisin. There is a fantastic article about him in Quantum magazine, where he describes where the thoughts came from and how it was that he met upon by chance another researcher, not Flavio del Santo, but Pussy, that really sparked this new take. We've known for quite some time, and I think indirectly in other terms, the physicality of information has come up to the fore. There is really no other possibility. Needs to be something in the universe that registers what has happened in the past and sort of also predicts the present. Determinism is today, I would say, absolutely taken for granted. Even one of the proponents, Dummett, called this discovery, or the very first take on this discovery, anti-realism. So we're confusing realism with the determinism. I think that holds for everyday language. It holds for everyone who's in thinking capacity. It's not an odd view, it's the general view. And I think now you start to realize the magnitude of Nicolas Gisin's proposal. It's an incredible earthquake. I read it the other day of something called earthquake storm. That is very similar. Humongous event. That will be the death life. I made a little Derrida reference here. The death life of determinism, or rather the death life of indeterminism. We know that information is physical. I think that is one of the claims that are not that radical. And since matter is finite in every square of space, if you like, think about 1 multiplied with 1 meter. The information there, if it is physical, it would be finite. In some way, it would be very big, yes, enormous, but it would be finite. And here is one of those things that build up classical physics. They're called real numbers. But the problem with real numbers, they take an infinite amount of information. A square meter won't be sufficient. The whole Earth will not be sufficient. Actually, the recent discovery of the biggest black hole in the universe will not be sufficient to hold not even 1 real number. And this is one of the great things that Nicolas Gisin is approaching head on. And it's not another thing here. We don't know the future because of lack of information. It is in principle impossible to foresee the future. That is very strong. And even to sort of take it up a notch more, now we're coming into that the past is also in principle indeterminate. The arguments he lays down are clear. They are decisive. This is going to be a very strong case for indeterminism in physics. And really happy to come upon it, but it's all new. Maybe my colleague Kalle here wants to have a comment. Give me a second. Carefully do it this time. That's not to stop it. Yeah.
I will ask two questions. The first is, can you say what is the most important phrase in this paper by Nicolas Gisin, and repeat why, in your words, why it's important? And the second question is, how can I, so to say, apply this insight more concretely? For instance, my own research, I have the problem of early manuscripts. Usually they consider better because they're earlier to the source, while later manuscripts are they are considered inferior because they're far further away from the source. So this has enormous historical implications, I suppose. So these are my two main questions. So the most important phrase in this paper by Nicolas Gisin, and for instance, is early and late manuscripts. How can we view? Is everything relative, so to say? Can late manuscripts be as important as early, or how do you?
There is actually three questions there, and the third one
Yes.
is everything relative, which is a very good question as well.
Mm-hmm.
So three questions. The most important was the rather a longish quote, almost a whole paragraph, and it contains the zest of it. It's in my edition, it's on page 6, beginning it with "it should be clear," and it ends, the previous paragraph ends with FIQ in big letters.
My edition, page 3.
Oh.
Page 3.
In an alternative edition, it's page 3. I will reread it with your permission. It should be clear at this point that a probabilistic view of causality entails indeterminism in the sense that empirical statements about the future are in general undecidable. They are neither true nor false, not even in principle. Very important. It is not only practically impossible, it is in principle. Even if you have the Laplacian demon, even if you have the omniscient knowledge of everything in the universe, if you are the panopticon, it will not make a change. Despite having complete knowledge of all existing information of the present pure states, this makes the law of the excluded middle fail, relating the problem of indeterminism and undecidability of empirical statements to mathematical intuitionism. In this way, propositions the likes of "it will rain in Paris in a year from now," or "the position of a certain particle will be on the left side of the plane at the future time Tf," do not have, at the present, a determinate truth value. Not because this might be unknown, but because it is not yet determined. And now I widen the quote, but it carries everything. Helpful for the understanding is also that one of the early proponents in a direction similar to Nicolas Gisin, Dummett, couldn't help but call it anti-realism. That is also helpful. We are all confusing Newtonianism, physics, with determinism. This is a very important helper in understanding this. I would say a powerful pedagogical didactic tool. You should question yourself and assume that you mean by real physics, you mean that it is deterministic. And I think that goes for most subjects of understanding today. It's not only physics, it's definitely biology, chemistry. Determinism governs everything today. So that makes the claim of Gisin so much more forceful, strong. The second question here is just a good one, and since this is pretty new, I started just a couple of days to think about original and history. But let me just give some proposals. According to what we found out, it is absolutely a possibility that what you do in the present with the text, with an original copy, will affect the past. The past and the idea that the past is cut in stone doesn't hold anymore. And you see, a lot of our thinking is based on that the past cannot change. And this, of course, goes against the very core of quantum mechanics. My proposal is just a suggestion, because this is early on, so don't judge me too hardly, is that there is a mixture between present interpretation, understanding, and what's going on, so to speak, before. But you need to question your idea of before, because it's all in the now, so to speak. The past becomes more like the Indian phrase kal, very close to future, if not the same. Undecided is a way of translating the Hindi Urdu term kal. The now, as I will get into briefly soon here, is viscous. That means that you cannot, as Xenon want to do, cut it in half and say this is a now. We know that, and that's called that the now is viscous.
Viscous?
Viscous. I'm going to write it down. It's very hard to pronounce. Viscös in Swedish. I think it's spelled this way. Viscous. Means thick. It's like molasses. It is like syrup or maple syrup. And that means we now know, and this is not only from Gisin, we cannot cut out the now. It is impossible, in principle. Because the cutting up principle also take the existence of real numbers, which there is no place in the universe for. The third question, is everything relative then? It's a very good question. And listen to what Dummett said, and I was saying until recently. Fundamental indeterminacy he called anti-realism, or saying anti-realism is almost the same as saying relativity. Everything is relative. It's not. It's not at all, because this is physics. It actually stops to be relative. So we're going from almost everything holds to a more definite way. And of course, this is just the starting point. I cannot oversee all the consequences of this. But of course, when the Indians don't even use it, which had a working society for millennia, we must be able to get rid of it. It's no longer in physics since almost 100 years. And to have this idea of a fixed past, we need to sort of lie to ourselves and accept something that actually cannot be accepted. I will continue with the text. Are you satisfied with the answers, or do you have anything to add?
No, I think it's...
We can get back to it later on. So I continue on page 9. What number is that in your edition?
Let's see.
Note it begins with.
Please repeat me. Note.
Before is a parenthesis ending with present time parenthesis, and then note.
About the which we call random past causal connections. See figure 2. This leads to the concept of open past.
No, note, however, that this construction maintains the desirable asymmetry between past and future.
Okay. Yes, it's page 5.
Page 5.
10th line, more or less, from above.
Okay, thanks. I would read the rest. It's a rather short article, and then I will go into, oddly enough, a more previous article, but it would be helpful for the understanding, and that's the reason I'll do that. And it is even more pedagogically constructed. Nicolas Gisin is a bit of a marvel when it comes to explain things, because it's a tough nut to crack, of course. Note, however, that this construction maintains the desirable asymmetry between past and future in a fundamentally indeterministic theory. Both the past and the future are thus indeterminate. And yet we can know more about the past and less about the future, as our intuition and experience suggest. This is important. There is a level of degree here. We know a higher degree of things approximately of the past than the future. The divide can be upheld, but it's not absolute. It's not death and life, as we said in the previous lecture. They come together. Note that this is in agreement with what also Dummett had in mind. Although with another basic construction, Lukasiewicz too, namely that the set of past events remained fixed, and once time passes, the propensities associated with a collection of n mutually exclusive events become homogeneous, i.e. 1 through n up to 8. No, that was a footnote. N through n. Since which one of the possible events has happened is now totally random. The information content is 0, and this remote past can be considered fundamentally erased. So future events can become fundamentally erased as leaving 0 trace. Therefore, it is just to say they never happened. In the same sense that the remote future, i.e. those events that have a totally random propensity associated with them, is fully indeterminate. Worth noticing is the position of certain authors, notably Albert, who has criticized the possibility of basing the distinction between past and future on records. This relies on the argument that independently of how much redundancy of information allegedly about the past, those are the records, one can observe at the present. It is always possible to account for it by statistical fluctuations. Albert proposes instead the concept of intervention. That is, the belief that the future counterfactually depends on present choices while the past does not. Our model, on the other hand, presupposes the existence of genuinely indeterministic yet causally related events. And this naturally provides a direction of time. The information about the past, the records in Albert's jargon, the records need to be seen through a thin line of present in the classical view, which we can call a now, and it looks upon a record of something that happened, something cut in stone, an original, something that happened but left a trace, maybe a stone cut another stone, or an animal died, or a plant grew. This now is very problematic because it's participatory in what is being of the record. It's not independent. This is something that has been proposed by, for instance, Carlo Rovelli in his QR theory, quantum relativity. It's important to understand that the present ideas of how we understand the past is far from unproblematic. It is exactly at these problems that Nicolas Gisin and Flavio the Santo in this article is putting the attention of the public. It is just coming about. It's a very recent thing. Speaking about the now, it is definitely recent. Let me go back to this. This is also quotable. On the other hand, our model begins with presupposes the existence of genuinely, and this is important, genuinely indeterministic yet causally related events, and this naturally provides a direction of time. The information about the past, the records in Albert's jargon, has the same nature of information about the future, namely both encode the propensities that relate causes and effects. The asymmetry does not arise from different statuses granted to past and future, but rather from the amount of information required to encode the causal connection about the past and about the future, respectively. That's another important thing. It is a bit like we randomly designate what is future and past. Here, Nicolas Gisin is clearly showing what the difference is, what it is to be past. It could be that our division is random or an obstructing dichotomy that blocks understanding of what is really going on here. Finally, the fact that the information recorded in the universe about the causal connection goes farther away in the past than in the future is not the only asymmetry between the past and the future in an indeterministic world. In fact, while future events eventually become determinate, as they happen and time progresses, the associated propensities for an event to happen will either become 0 or 1 eventually, not none, and in principle undecidable until it happens. So every statement will become decidable for a certain time. The information erased from the past is forever lost, and past statements will forever remain undecidable. This was already hinted at by J. Butterfield. Quote, Dummett's idea tends to condemn the past to a more endemic unreality than the future. For on the one hand, singular observational statements about the future seems effectively decidable. We naturally envisage making an expedition to the place and time in question with instruments, not just detached observance, if need be, in hand. On the other hand, the analogous statements about the past, there is no such procedure. In this sense, the openness of the past becomes wider and wider as time passes. It was asked earlier by Kalle. As the centuries fly away, it gets less real, less original. To conclude, we would like to clarify that the toy model here, it is a metaphor for understanding, here presented has no claim of being any close to the real mechanism that erases the past as time passes. It is intended as the simplest conceptual way to formalize the idea that the past can be open in an indeterministic world, while maintaining the desired asymmetry between past and future. We hope in this way to stimulate further debate on the topic of indeterminism and its implications on our way of understanding past, present, and future in indeterministic theory, possibly within quantum mechanics as well. That was the end of that article. I will try to give you a bit more.
Already 1 hour 39, so
Okay,
I don't know if it's...
we make a summary instead. I just want to mention briefly another paper that I hope to be helpful here, but I won't go into it. And it's called Time Really Passes. Science cannot deny that. So this whole thing started also quite recently by Nicolas Gisin out of the conception and inner understanding that time does fly, tempus fugit, and that time does things. And this is close to what we mentioned earlier by Lee Small and Roberto Unger, that time is real. The reality of time is something we experience, but we, because of, if Nicolas Gisin has a point here, which I think he has, is because of this deterministic tendency. And it will change a lot, of course. This is an opening up on all areas. Because since determinism, I would say, accidentally entered into the Newtonian understanding, it being spreading all over society. And that's the first time I repeat that, but the mistake of Dummett to say denying determinism is being anti-realist does not hold at all. And I think that is an important argument to put down to help ease the understanding of what these two things means. Another thing is that it is very close to what we read about Derrida, for instance, difference, where there is a constant happening and you can exchange now here with the subject because they actually amount to the same thing. The subject reads something here and in the now. And what is the subject if not here and now? I would say that is exactly what it is to be a subject. We've been denying the role of the subject, of the observer. And this idea of Nicolas Gisin is taking it a notch higher, really bringing it in. But what happens, I was thinking about this last night, it left me sleepless, but what happens is that everything comes to make more sense in the end. Things become more understandable, not less. This brings in quantum mechanics to all the areas previously so affected by determinism that we mistake them for realism. And the idea that there can be no reality without determinism, which is so closely connected today, almost to be an immediate truth. So even the person attacking this, like Dummett, cannot take them apart. And that is the fifth, I found 5 good things with Nicolas Gisin. That's the 5th good thing. He keeps realism, actually. He enforces it by, so to speak, bringing in quantum mechanics into an understandable level. Indeterminacy is here to stay, I think. But it's time for some comments, and I should later put something on the whiteboard as well. Check that you are.
Well, in my edition it was page 5. I think it's a good idea to repeat the conclusion. We would like to clarify that the toy model here presented has no claim of being any close to the real mechanism that erases the past as time passes. It is intended as the simplest conceptual way to a formalized idea that the past can be again open in an indeterminist world. but maintain the desired asymmetry between past and future. So the key phrase here is they want to form this idea that the past can be again open in an indeterministic world. And in the previous paragraph, they refer to Butterfield, who commented on Dammet, that about the instruments. That is, let's say, we envisage making an expedition to the place and time in question with instruments, if need be, in hand. On the other hand, for analysis statements about the past, there is no such procedure. Why would it be only possible to take these instruments? Let's say, if you are predicting the weather, why cannot you also do that for the past with instruments? Of course, you can. Now we know what the weather was yesterday, or do we know it? You cannot calculate every piece of weather on this planet of yesterday. I think it's impossible. And the same way, even what I did yesterday or 2 days ago, I don't always remember in which order I did them 2 days ago. So it depends on my observation and memory. And since let's say, if you have work on study manuscripts, sometimes it depends on the observation, what we happen to find. So why is early manuscripts more precious than the late manuscripts? I'm still asking myself that question. From quantum physics, what would quantum physics say? I don't know. It depends. It's a tricky question. For historians, obvious is closer to the fact, but on the other hand, it can be more biased also. So who knows? So I don't know. And another thing, you mentioned this word earlier. I checked the spelling is spelled like this. Viscosity. And why did you mention it in this context? Can you please explain this and my ramblings?
Yeah, no ramblings. It's quite all right. This is a tough nut to crack. Viscous was actually coming in the next article here, but let me just... the idea that we can have a thin line of now is impossible. That is what I mean by the now being viscous. We cannot take a knife to cut the continuum of time like Xenon wanted to do and so many others, to make a clean cut, because it's based on a misconception of what a half is, and it has to do with real numbers. Xenon didn't know what a real number was, but he had a pretty good intuition that they should exist somewhere. They don't. It was an implicit assumption from Xenon's idea, so to speak. And therefore, we now know today, this is not an adventurous thing to say, that the now cannot have a thin line. It is extended. Maybe one way of explaining it is that the now in many cultures are an extension, what we would call a couple of hours or half an hour, whereas we get the idea that it is possible to have a moving now on the timeline. Let's see if I can erase without causing any havoc here. Let's see here. Thank you. I will not go into the alternative explanation. That will be in a later lecture, but I will show the general idea of the present idea. Time like a line like this, and then we have a now, and that now is moving into the future. Can you see the likeness to Xenon's paradox here? And it seems that it is forever divisible. That does not hold. We know that to be an impossibility. So Zenon's paradox also dies here. The now is viscous, it has extension. It's not the logocentric metaphysics of presence. And that's why I really like that other little depiction I made. That the present and now and the here reads the record. And the record can be your manuscripts, but of course Dummett was talking about something that happened, a cracked thing, an atom that hit something and left a mark. It needs to be trace. That doesn't hold, because the subject now that doesn't have an extension in space nor in time is wrong. And that makes, of course, the foundations that Nicolas Gisin is standing on much more powerful. It makes it stronger. The viscosity, I will get back to though. It is in another article, very interesting. Time really passes, science can't deny that. It's a short one, it's an easy read, and it takes up how we also can have a free will, or even that free will is a necessity. It is built into the universe.
1 hour and 52.
Okay, I just round up here. I'm very happy to share this. It's, so to speak, it's a scoop, as newspaper agents would say, and it's absolutely fresh from the press. It's like grabbing a newspaper inside the printing hall. I done that when I worked in the newspaper, and you still feel the ink being a bit sticky, not completely dried. This is by the Nicolas Gisin, and I'm sure my prediction is, you cannot know anything about the future for sure, of course, so it's a prediction, a prophecy. I think that this will be a major earthquake in the scientific world. He is slowly turning up on different channels as well. Recently he was interviewed by Kurt Jamungal. So he's coming up, and it resolves problems I've been thinking about both consciously, but I say much more unconsciously. That bugged me or set my thinking into certain undesirable directions of determinism. Because determinism, it's not nice. It sort of spoils everything. And even those people who accept it seem to have objections to it. It makes everything fatalistic in a not a nice way. Having this objection coming from quantum mechanics as well is a definite step in the right direction, and it will have tremendous implications on how we live our lives. Well, I will round up there. Still morning. I say thank you very much for your patience and have a very pleasant day. Bye bye.